Alright guys, so for this section, weirdly enough, they didn't include a checkpoint. So instead, I'm going to kind of go over these a little more informally, typing them up or writing them in as needed. So these, instead of going over the entire study, I thought I'd highlight what seems to be the most important thing. So which of the following can be used to explain a statement in a geometric proof? So for your explanations, you could use things like corollaries. Okay, they are kind of like a simple theory, a little shorter. They don't require a proof. We can use a full-on theorem. So if we have a theorem, vertical line or vertical angles are congruent, and we've proven that, we can use it. We can use any type of postulate. Postulates, again, they're kind of statements that you might be given that don't need to be proven. And we can also use any type of definition. So those are the type of things you're going to see for filling out a geometric proof. They kind of go on the right side of your column proof. These are the different type of things. So the next question is a true or false question. And it's dealing with indirect proofs. So in the body of an indirect proof, you must show the assumptions lead to the contradiction. So an indirect proof, another way of talking about it is an indirect proof is assuming the opposite of what you want to prove and you arrive at that contradiction. So what we are trying to do is whatever assumption we make leads to a contradiction. So that is what an indirect proof is trying to say. Okay. So postulates. What is a postulate? Are they statements that require a proof? No. A postulate is kind of like a very short statement. It does not require a proof. Okay? So postulates do not require a proof. Make sure if you get a question like this on the quiz, you read through it. They are accepted as true without a proof. So that would be true, but postulates are statements that just don't require a proof. Okay? Number 4 here. Postulates. Corollaries. Corollaries are statements that can be easily proven using a theorem. That's true. So basically, a corollary is an attachment to a theory. So, you know vertical angles are congruent. What would be attached to that? So it's a simple addition statement. So it's easily proved off of a theorem. That is true. The opposite is not true. So theorem statements, they cannot be easily proven with a corollary. So it goes corollary to theorem, not theorem to corollary. Corollary. Oh, I can't say that word. I'm sorry. Now, which of the following are accepted without proof in a logical system? So postulates. We kind of saw that before with the previous one. Postulates are statements that we can just assume to be true. Axioms. Again, axioms are something that are like our building blocks of any knowledge. We have that basis. Common nouns. So I don't need you to prove that your name is John. It's just what it is. So it's common that we all know about. And the other thing that we don't need to prove are definitions. So if I tell you the definition of a line is the connection of 2 points, I don't need you to prove to me what a line is. That's just what we as English speakers or non-English speakers, geometry students, understand a word to mean. All right, so in a 2-column proof, the left column is a series of deductions. So a 2-column proof, I might say A equals B because given, something like that. This left side, that's a deduction. I know A equals B because of whatever reasoning. The right side is your reason. So a two-column proof, so this is also true. So in a two-column proof, the right side of your two-column proof is explaining why something is true. So I know A equals B because it's given. I know U will show up to geometry class because it's given. It's some type of reason that it's given. Which term best describes a proof in which you assume the opposite? So this actually goes back to our previous question. When you assume the opposite of something, that would be a proof by contradiction. Okay? So if you're assuming the opposite of something, you are proving the contradiction. So look for the term contradiction on your quiz. And then the next one says, like, what would be the best meaning of a theorem? So a theorem is a conclusion that is proved by deductive reasoning. And you're going to see that more once we really start getting into some of these proofs, what they look like. But what we want to be able to do is say, because of this, this, and this. And so we can really get to a firm understanding, not because I think something's true, but because I went through the deductive reasoning process. And so that would be a good working definition for us to have of a theorem. And then an argument where you use boxes and arrows. So, you know, you have a box that it comes over here, and then it goes over here, and then it goes down there, and they're all flowing together. This is called a flowchart. Okay, so we may see some of those, whereas instead of the two-column proof, we just kind of flow around. So that is an argument that uses boxes and arrows, is a flowchart. So this is some of our working definitions that we're going to have for this course. Again, this video should make your quiz very easy, and we'll jump more into proofs and your checkups next class.